आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start the question. The question says that write the type of magnetic observed when the magnetic moments are aligned in parallel and anti-parallel direction in unequal numbers. And here we have a second part also, which stoichiometric defect decreases the density of the crystal. So let's start with our first part. Here, alignment of magnetic moment in opposite direction resulting in a net magnetic moment due to unequal number of parallel and anti-parallel magnetic dipoles, which give rise to ferrimagnetism. So here, when the type of magnetism observed when the magnetic moments aligned in anti-parallel direction in unequal number, then this type of magnetism is known as ferrimagnetism. Ferrimagnetism. So this is known as ferrimagnetism. And here in let's see our second part. So in second part it is given that which stoichiometric defect decreases the density of the crystal. So that is vacancy defect. Vacancy defect. When some lattice site left vacant while the formation of crystal, the defect is called as vacancy defect. So let's take the example of solid crystal. Suppose this is the lattice of solid crystal. So this is the lattice of solid crystal. So in this case, a vacancy is produced when an atom is missing from its original site. So when suppose this metal, so here this is the empty lattice. So this is the empty lattice. Empty lattice. Empty lattice site. So because of this, like other point defects, vacancy is also a zero-dimensional defect. And vacancy defect put the neighboring atoms. So these are the neighboring atoms. So neighboring atoms under tensions. And due to reduction in the number of atoms in the crystalline solids, valency defect results in the reduction of density. So this leads to the reduction of density. So in case of crystalline solid, suppose this is the example of crystalline solid. So in case of crystalline solids, the hardness of solid increases. So because of this, the hardness of solid increases. In other words, we also say that due to Schottky defect, due to Schottky defect, due to Schottky defect, vacancies are formed. Vacancies are formed and density decreases. So let's see here. So this type of defect is created when one positive ion and one negative ions are missing from their respective positions. So let's see the structure. Suppose this is the structure of a crystal, and here the positive and negative ions are placed. So here let this will be the positive ion, and here we have negative ion like this. Here it is positive, then negative, then positive, positive, negative, negative, positive, positive, negative, then negative, and here we have positive. So in this case, when the one negative or one positive ions are missing from their respective position, leaving behind a pair of holes. Suppose this will remove from this place, and here let's take this negative ion get removed from their place. One positive and one negative ion are missing from their respective position, leaving behind a pair of holes here. So shortcut effects are more common in ionic compounds with high coordination numbers where the size of the positive and negative ion are almost equal. So in this case, the presence of large number of shortcut effects in crystal result in significance in its density. So from this here we can say that it due to shortcut effect vacancies are formed and the density decreases. So, and this type of defect is known as vacancy defect. Thank you.
क्लास 6 से 12 से लेके नीट IIT जेई मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।